Did you see it? Did you see it? Welcome to the latest and greatest in geometric transformations video. In this episode, we will be exploring dilations. You'll see how these transformations are a little bit different from our translations, reflections, and rotations. Enjoy your experience. So what is a dilation, you might be asking? Well, you're looking at them right here. The blue is the original, and you can see that the green one has been enlarged, and the red one over here has been made smaller. So how have these two transformations been made? Well, I can't just tell you that. We're going to take a little journey together and explore how those transformations were created. We're not going to be able to understand any dilation rules unless we actually look at coordinates here and try and see a pattern or relationship. So we need to look at coordinates. Look at coordinates. So do you see any relationship amongst the coordinates corresponding vertices here? How it got enlarged, how it shrank, anything? Anything you see there? Well, there is a scale factor involved. You can see that all the coordinates of the enlarged figure have been multiplied by 2 from the original. And to make the shrunken figure, all the coordinates have been multiplied by 0.5. So scale factors are involved to make the coordinates enlarge or shrink, and that's how we make a dilation.
Excellent. Absolutely excellent.
So all we need to do to make a dilation is to multiply the coordinates by a scale factor. Wait, say that again? Yeah, all you have to do is multiply the coordinates by the scale factor and you make a dilation. So let's verify that this scale factor thing is working. Let's see it in action here. So let's take a set of corresponding vertices, 4, 6, and 12, 18. The blue one is the original, the green is the dilated figure. Find the scale factor here. So do you see how 4, 6 becomes 12, 18 by a scale factor of 3? Yeah, all you gotta do is multiply both x and y numbers by that scale factor and you'll get your new location of your coordinate. So pause the video and verify that the other two coordinates of the corresponding vertices follow the same rule of a scale factor of 3.
You have got to be kidding.
So hopefully you saw that it did check out. So on this screen, let's do one in reverse. Let's make a shrunken figure.
No!
Well, we need to practice, so we're going to go ahead and do this anyways. So the blue, again, is our original. And let's take corresponding vertices here. 824 goes to 26. How did that happen? What's the scale factor here? Hopefully you can see that the coordinates here are going to be dividing these by 4 to make the new coordinates here. But a scale factor means multiplying. So we need a factor number that we can multiply these numbers by to make smaller numbers here.
Does not compute.
So pause the video right here and find what the scale factor would be. Alright, let's check it out. So dividing by 4 or multiplying by a scale factor of 0.25 is what would take these coordinates and make these coordinates, and therefore making this figure shrink to that figure. So pause the video and verify that the other 3 vertices check out in the same way. So what are our key takeaways here from this lesson? Well, we need a scale factor involved to make a dilation. Hopefully you're seeing that every time we enlarged or shrunk a figure, that position is going to change. And this is the one and only transformation type that results in a similar figure rather than a congruent. Translations, reflections, and rotations made an exact copy, which we call congruent, and dilations make similar figures. So let's wrap this up. So if you have vertices A, B, and C with those coordinates listed, and you are going to apply a dilation with a scale factor of 4, find where the new coordinates would be. Take the time to work this out, and thank you for watching. Have a great rest of your day.